This video is going to go through how to use zeros to write out polynomial equations. Similar to the method that we use for quadratics, we are changing our zeros to factors, and then we're taking those factors and we are going to multiply them. You're looking at these couple of notes. The examples are written out for you step by step. And in example 1, we're looking at writing a 5th degree polynomial where 4 of the zeros are 1, which is a double root, meaning it occurs twice, which is why you have here first and second. The being 1 becomes x minus 1 and another x minus 1. Having x be negative 2, we end up with x plus 2 as a factor. And then finally, 2i is a factor. So we end up with x minus 2i. But if you remember, please don't forget, when we have imaginary solutions, they do come in pairs. So not only do we have 2i, we also have negative 2i, which, as is written here, becomes x plus 2i. Okay, so we do have that additional root. They always come in conjugate pairs. Please do not forget that. And you also, this is a degree of 5, so you should have 5. 1, 2, 3, 4, 5 different solutions. So we have 5 new factors. Once we have all of those factors, we are now going to multiply just like we did for our quadratics. For the irrational or the complex zeros, right? Irrational meaning radicals, complex zeros having I. Since they come in pairs, we're going to set that pair equal to equal to x, just like we did with the quadratics. So we end up with plus or minus 2i here. We square both sides, so we get 4i squared. The I squared, right, remember, becomes negative 1. So that becomes negative 4. So x plus 4 is now our factor. Okay. When we do that, we write it out in factored form. We have x minus 1 twice, x plus 2 once, and then x squared plus 4 as our last factor. Okay. With all of these factors, we will not be expecting you to write them out. Multiply them out completely, but in some cases you will, in some cases we won't. In the next example, we're going to write a polynomial function of least degree with integral coefficients that have the given zeros 0 and 3i. So the least degree for this is actually going to be 3. Why is it 3? Because our 3i is also negative 3i as another 0. Remember, they come in conjugate pairs. So we're going to write out our zeros as factors, right? So our first 0 is x. So that factor is just x. X equals 0, so it's just x. Our second factor of x equaling plus or minus 3i, or 0, comes to now we have to square both sides. So we get x squared is equal to 9i squared. I squared, as we know, is negative 1. So this whole expression, we solve it for 0. X squared plus 9 equals 0. So our remaining factor is x squared plus 9. So the polynomial in factored form, f of x equals x times x squared plus 9. And that is the factored form. Okay, your homework is to complete the rest of this practice and writing everything out in factored form.